So in this class, we are not going to waste much time. We are going to quickly rush into the answering of the question. We had our solving of the equations that we had from the previous question paper, from the previous class that we had working with the full paper. So as a request that the determinants was something that was maybe difficult to understand, can we work with the elimination method? So actually, it's not the elimination method that we are going to use, but we are going to use the substitution method. So I want you to consider, if you have not watched the class, make sure that you watch the video on the April 2024, which is the full paper. All right, so we had these equations. If you still remember, we are given current 1 minus current 2. When we formulated these equations. This was equal to -3. And we are also given 2i1 minus 3i2 minus 7i3 is equal to 4. Also, you were given i1 plus 5i2 plus 3i3, which is equal to 6. So these were the three equations that you were given. So I want us to see how we're going to solve our equations. So let us just say this is our equation 1, this is our equation 2, and this is our equation 3. So like I said, we are going to use the substitution method. We are going to work with the not the elimination, because elimination is going to be difficult. Again, remember, you must eliminate I1, get rid of I1 totally, which is going to be something else. Okay, which is going to be something else. So how can we use the substitution, which tends to be an easier method, though it's lengthy, just that we've got a lot of substitutions, but it's very, very easy. I want you to get rid of this. So this is what you're going to do. You choose the part where you can make any one of these equations the subject. It's either from equation 1, you make I1 the subject, or you make I2 the subject, or you make I3 the subject. It's up to you. But you must choose a part which is easier to make the subject, where the coefficient of that number is a 1, like what we see here, which is a 1, like what we see here. There is a -1 also, which is fine. We must choose where there is a 1. Where at the end, when you're working with the 1, guys, it's easier to just make that the subject, or where there are numbers such as 2, these numbers such as 2, because if you divide by 2, that is the easier part. 3 over 2, it's 1,5. 7 over 2, it's going to be just 0,5, 0,5, 0,5. So even if there is a number, you can choose the number such as 2. Do not work with 3. Just remember, 3, if you divide like 1 over 3, that's 0,3333, and so on. So working with those decimals, guys, we want to just avoid that. Just want to avoid that. So working with numbers such as 3, 7, these numbers, they're very, very difficult to work with. Numbers such as 6, 3, and 6, remember, they are just one and the same. 11, 18, such numbers, they're difficult. But if you work with the 2 to divide by 2, a 5, maybe there's a 10. Yeah, these three numbers, they are very, very easy, because if you divide by 2, it's going to be 0,5. Again, by 5. By 10 is just like, if you divide 7 over 10, is just like 0,7. We're not going to have those endless decimals, 0,333, and so on. So if you choose, I'm just saying this, if you choose to work with where there's a number, like maybe someone can just, I want to work with the, people, they differ in how they solve. You choose according to what you want. But it is easier, like I said, to work with where this as having the coefficient, the number that is there is a 1. So you can choose to work with equation 1, it's a choice. Make I1 the subject, it's a choice. Make I2 the subject, it's a choice. You can choose even from equation 3, there is I1 there. Make that I1 the subject, is a choice. So in this case, as for me, I'm going to choose equation 1. So from equation 1, I'm going to make I1 the subject. So in this case, I'm going to make I1 subject. That is I1 from this. So it's simply transposing this to the other side, and so on. So from there, it means I1 will be equal to, if we take I2 to the other side, it's going to be a positive. It was a negative. If we take this to I3 to the other side, it will be a negative because it crossed an equal sign. So that's minus 2 I3. Already, there is a minus 3, which is on the right-hand side. So this is not affected at all. It's already on that side, which is the right-hand side. So it's not going to be affected. So we have formed another equation from equation 1. We made I1 the subject. That's another equation that you can consider. So we're just going to call this equation 4. All right. So the way that you also write your equations, it's fine. Even if you do not write like this is equation 1, this is equation 2, guys, you just understand what you're doing. It's fine. But just writing, it's going to even help the one that is marking your work to follow up these steps that he knows, okay, this is your equation 4. Okay, so what is the purpose? Remember your substitution, just like when you're working with two unknown values. You were having maybe x plus y, maybe 2x plus 3y is equal to something like that. You make this the subject. What we're going to do, you're going to substitute the part that you have made the subject in another equation. But this time, since we have 3 equations, we are going to substitute this I1, which is the part that is representing I1, in the 2 equations that are remaining. Remember, we made I1 the subject from equation 1, from equation 1 here, from this equation 1. We made I1 the subject from equation 1. So you substitute in the 2 remaining equations. You do not substitute where you made the subject. Just like your normal, when you're given 2 equations, you are going to substitute in the second equation. But this time, since there are 2 equations, you must substitute in those 2 equations that are remaining, the I1 that you made the subject. All right, so this is how it's going to look like, guys. I want you to see. So let us just say substitute. So you're going to substitute equation. So it's now equation 4. So you're going to substitute equation 4 into equation. So you're going to substitute into equation 2, the remaining ones, and equation 3, which are the remaining ones from what we are given. So this is what is going to happen, guys. In place of I1 from equation 2, so we're going to start with equation 2. From equation 2, let's substitute. So that is 2. In place of I1, we're going to substitute its equivalent. What is equivalent? That is I2 minus 2, I3 minus 3. We have substituted in place of I1. Then the rest, we're going to write as it is. That is minus 3, I2 minus 7, I3, which is equal to a 4. So let's start. Remember, we're supposed to substitute equation 2 and equation 3. But as you have substituted, guys, just try to simplify. Do not just substitute and leave it like that. Simplify. As you can see, there are now 2 unknown values, I2 and I3 only. So let's try to solve this. let's try to simplify a little bit further. We can expand the brackets by 2. 2 times I2, that is going to be 2I2. 2 and minus 2, that will be minus 4. I3 is, okay, multiply this, that will be minus 6. You also combine, okay, this part is just right as it is. Minus 3, I2, minus 7, I3 is equal to a 4. So let's simplify, guys, as we are to consider where there is I2. We've got I2 here and also I2 here, which is current 2. That is 2 minus 3. So what are you going to have there? That is minus I1. That is minus I2. So that like minus 1 I2 like this. So it's just going to be minus I2. Okay. So that is what you obtain from there. Then consider I3. There is current I3 here, which is minus 4 and minus 7. So minus 4, minus 7, that is minus 11 I3. Then take the number to the other side. That will be a positive there. So it's going to be a positive 6. So meaning to say this is equal to a 10. So we have an equation with I2 and I3, only 2 currents, only 2 unknown values that we have formulated when we substituted in equation 2. So we are going to continue as usual our equations, guys. Remember, we were at equation 4. So we are just going to call this equation 5. All right. So I'm just going to refer this as equation 5. With the same concept, remember you're supposed to substitute where? Into equation 2, which is what we have just done here from equation 2. And also the remaining one, which is equation 3. So we are going to substitute also the same I1. Remember what we are substituting, which is our equation 4. This I1 here, which is in equation 3. So this time we're going to substitute in equation 3. Guys, you see, these softwares, they just tend to misbehave whilst you want to explain something very important. All right, let's see what we got here. So from, like I said, equation 3. So from equation 3. So from this equation 3, we are going to substitute the same I1 that we had, or the same equation 4. Remember what your substitute is equation 4. So in place of I1, we are going to substitute this as it is in place of I1. So that is going to be I2 minus 2I3 minus 3. So we are substituting in place of what? In place of I1. Then the rest of this part of the question is going to remain as it is. That is plus 5I2 plus 3I3. So there we have got plus 3I3, which is equal to 6. So that's what we have. Let's try and simplify this and see what we are going to have at the end, just like the previous case. So we have formed another equation here. So let's consider current 2 and current 2. So this is just a 1 here. So the 6 plus, 1 plus 5, which is 6. So you're going to have 6I2. Then let's consider I3 and I3 here. So this is minus 2 plus a 3, which is plus 1. So we're going to have I3. So it was supposed to be like this. So it's just gonna be I3. Also, we can transpose the minus 3, which is the constant, which is the number, to the 6 on the other side. That will be a plus 3. So meaning to say this will be equal to 6 plus 3, which is a 9. So we have formed another equation from the equation 3 by substituting our equation 4, this one, with I1, the subject. So as we can see, we were at equation 5 from the previous one that we had here. This was equation 5. So we're just going to call this equation 6. All right. So this is it now, guys. I want you to understand this part. Clearly, we can see that from these two that are remaining, these two equations, this equation, which is our equation 5, this one, and our equation 6, clearly we can see that there are now two unknown values, I2, I3, I2, I3. There are two unknown values, guys. This is what we are used to. These are the equations that we have been working all along from our N3, N2, working with the two unknown values. So now that you have got these two equations, you can solve the way that you want. That is where now you can even apply that elimination that you were saying here. Using elimination, there you can even use elimination because you're just left with the two unknown values. So in this case, you are going to focus with equation 5 and 6. Solve equation 5 and 6. So you're going to solve equation 5 and 6 using any method of your choice. From there, it's going to be elimination, it's going to be substitution. So as for me, guys, I'm just going to consider that same substitution. So we have got the first equation, that is minus I2 minus 11 I3, which is equal to 10. Remember, that's our equation 5, and our equation 6, that was 6I2 plus I3, which is equal to 9. That was our equation 6. So it's up to you. You're going to use elimination where you multiply this by 6, this by 1, so that you eliminate I2. That is up to you, guys. Or you can just use substitute, because as you can see, it's easier for us to make I2 the subject. It's also easier for us to make I3 the subject. It's up to you. So in this case, I'm going to choose equation 5 from this equation 5. From equation 5, I'm going to make I2 the subject. So to make I2 the subject, I'm just going to take it to this side so that it becomes a positive, or I just leave it there as minus I2 as it is, then transpose this 11 this side, so it's going to be a positive 11 I3, then a 10, which was already on this side. But this is not I2. So to obtain I2, just divide by -1 by -1 on each and every part. So meaning to say I2 is equal to what? Negative into this, that's negative 11 I3. Then it's going to be 10 divided by -1, that's a -10. All right. So there I have formed another equation, as you can see. So I'm just going to call this equation. We're now at 6. So I'm just going to say this is 7. So remember, I'm using substitution method in this case. So like I said, I'm going to use substitution method. So using the substitution method, I make I2 the subject from the, remember guys, we're just working with these two equations. It's just like this is equation 1, this is equation 2. You make the subject from equation 1. What do? You substitute in the other equation. So this is what just happened. We made equation the subject from equation 5. So we substitute in the other equation, which is equation 6. So we are going to substitute our equation 7 into equation 6. So by doing this, you are going to see that 6 into, take note, I2, and I2 is this part, which is minus 11 I3 minus 10. We substituted in place of I2 into the other equation. You don't substitute where you made the subject. If you make the subject from equation 6, you substitute in equation 5. Because if you substitute back, you neutralize the question. You go back to the original question as it was. So do not make that mistake. All right. So the rest of the question will remain as it is. That is plus I3 is equal to 9. All right. So this is an equation that we have formed by substituting I2 in place of I2 of equation 6. And as you can see on this equation, there is only one current to be considered, which is I3. There is no I2, there's no I3 there. I mean, there's no I2, I1, and just one current. So in this case, we can solve. For what? For current 3. We can solve for this value. It's just one value left. One unknown. So you can solve usually, as usual. Expand your brackets. This is a linear equation so that we can collect our like terms. So this will be negative 66 I3, 6 times this. That will be negative 60 plus. So this is going to be plus I3 is equal to 9. All right. So let's solve for I3. We can collect like terms. I3 and I3 here. This is a 1. So that means you're going to have negative 66 plus 1, which is negative 65 I3, which is equal to, transpose the negative 60 to this side of the equation. It was a negative, so it's going to be a positive. So that's positive 69. So that will be a positive 69. So you can divide by negative 65 by negative 65. That means we have got I3, which is negative 69 over 65. All right, so that's our I3, or you can write it as a decimal. I3 will be equal to negative 1,062 to 3 decimal places. That is our current I3. So as you can see, that is exactly the value that we obtained for our I3 using those determinants. Using the determinants. So that we have got, that we have obtained this current 3, what are we going to do? We have to look for an equation that consists of I3 as the that consists of I3 from another current, which is being the subject. Maybe it's I2 in terms of I3. Maybe it's I1 in terms of I3. Let's check. Is there an equation like that? If you check on equation 7, on this part, on these two equations that we're solving, remember we made I2 the subject from equation 5. We formed equation 7. We can see that I2 is the subject written in terms of I3, only I3. So we can take advantage of that. Substitute in this equation 7, we can calculate our I2. So I2 is equal to minus 11 times the current 3, which is the one that we just calculated now. So in order for us to obtain exact values, because this one is a rounded off value, so for us to obtain the exact value, just substitute the fraction as it is. That's negative 69 over 65. So we're going to substitute this in place of what? In place of I3, but there is a minus 10 that we are given there. So after this, we're going to subtract a 10. So this was going to give us I2. As a fraction, it was going to be 169 over 65, which is actually same as 1,677 amps. All right, so this was going to be our current 2. So again, since we have determined our current 2 and our current 3, we must look for an equation where there is current 2 and current 3, but I1 being the subject. So which equation is that? If we check when we started this substitution, the very first equation, this one, where we started our the very first equation there, which is our equation 4. From these equations, when we made from equation 1, we made I the subject. That is I1 in terms of I2 and I3. Now that we have got our I2 and our I3, let us substitute back into that equation 4 that we are given. All right, so I'm just going to write it back here so that we can see properly from our equation 2 and equation 3. All right, sorry for that. Let's just try this one. I think it's fine. All right, so we're going to go back to equation 4. From equation 4, remember from equation 4, it was given that I1 is equal to I2 minus 2 I3 minus 3. That was our equation 4. So you can substitute these values to obtain I1 because we have I2, we also have I3. So like I said, to just obtain exact values, just try to obtain, to substitute the fraction. By substituting the fraction, you obtain exact values because these are rounded off values, all right? So I2 as a fraction, that's 109 over 65 minus 2 times I3. Remember I3 here as a fraction, that's negative 69 over 65 minus 3. So by having this, we are going to obtain the exact value of our current 1 from this substitution, which was going to be 4 over 5 as a fraction, as a decimal, that is going to give us 0.8 amps. All right, so we're going to obtain the exact values just like the previous case that we had. So that is it, guys. We have got our currents, that is our current 1, our current 2, and also our current 3 by using the substitution. As we can see, it's substitution throughout. But like I said, elimination can be used at this point here when we have these two equations. At this point on equation 5 and 6, we can use our elimination method here. Elimination can be used at this part. Elimination can be used. So in this case, elimination method can be used at this stage. All right, you can use elimination. You eliminate I2, it's up to you. You eliminate I3, it's up to you. Then after that, you substitute back the value that you have obtained from the calculations. Then after finding I1, after finding I2 and I3, still you must refer back to your I1 there. From that equation, you can substitute where you made I1 the subject. But it does not mean that even if you substitute in any of these equations, as long you have I2 and I3, you can even substitute in this equation too. Substitute I2 and I3, you can calculate I1. You can substitute in equation 3, substitute in place of I2 and I3, you can still calculate I1. So it does not mean you have to substitute on this, but here it's clear because already I1 is the subject written in terms of I2 and I3. So you can take advantage of that. So this is how we could have solved these simultaneous equations from the one that we had of the determinants. We could have used this part. So I do not know if we are answered. If not, Guys, let us communicate on the comment section so that we can work on it. But that is it, guys. From Math Zone African Motives till we meet again.